Okay, guys, it's 11 o'clock. Let's start. Okay, buckle your seatbelt. So these are the objectives, blah blah blah, and let's start about something very interesting that if you never thought about it, the kidney is actually a modified gland. So there is a part of the gland that is actually synthesizes the secretion. And then there is the second part of all glands. You have a duct system or simple duct or duct system that collects the secretion and carries away for the right location, right? So kidney is actually, there is a place where you make the urine, and you also have, specialized ducts where the urine is carried away. And the secretion itself is the urine. Okay, so now this is the way you're gonna see the kidney we used to have Mickey Mouse heart, now we're gonna have Mickey Mouse kidney. What is special about the Mickey Mouse kidney? That it has only one lobe. Wait a minute, can I make a better of this? Pointer. There's no pointer? No. Yeah. Okay, that's what I wanted. Okay, so you see it's only, the Mickey Mouse kidney is only one lobe. Let me show you to you. One cortex outside. This is one continuous medulla in the middle. Medulla means middle. And the tip of the lobule lobe is papilla. Okay, so if you compare this, I use at the beginning the images of the model because it's easier to understand from the model. And then we switch over to the microscopic slides, okay? So look at this. I just circled for you one lobe. But in human, you really have 7 to 18. Okay? So now here you have one magnified lobe separately. And what you see is there's a brown capsule. Then there is a cortex. And there is a medulla. And because the medulla has this pyramidal shape, you're going to call it renal pyramid, renal medullary pyramid, either way is fine. But it has this shape, okay? And at the tip of the pyramid is called the renal papilla, as it's labeled here with P. This is also the territory of the area cribrosa, which I'm going to explain in a minute. I can't, but better to label it from the beginning, but I have to explain that to you later. And now we are entering the minor calyx. Okay? So what about on the right side? What you see is a little yellow balloon, which is called the renal corpuscle. Okay? So this is one magnified. All of these little yellow envelopes are all the same here. Okay? And then, and here these little yellow fellows in the cortex, the same again. So what you see is the balloons are getting bigger, and one large. Okay? So this comes when I'm always hoping that you remember the principles what I taught you in cardiovascular system, that when you have a microscopic hollow organ, how many layers do you see histologically? Micro. One. What I just said, in general, you can think tunica intima. And what you're going to have there is, in the cardiovascular, usually what epithelium? Simple stemless epithelium, what we call endothelium. Yes. Now we're going to translate the same principle to the urinary system right now. But what about the macroscopic, what I call macroscopic hollow organs? Three layers inside epithelium. Endothelium in the blood vessels, but not in the nephron, not in the urinary system, only in blood vessels. Endothelium, then what's in the tunica media? Smooth muscle. And what's in the outside? Tunica externa, little bit of connective tissue. So where am I gonna make urine, guys? Which part?
Intima?
The micro or the macro?
Micro?
You have to do at the micro. You have to. Because what we really do when you are making urine, that you are cleaning the blood.
Yes.
So what we're gonna do is, during the lecture, that we're gonna have the microscopic simple epithelium of the kidney part, and we put next to it the the capillary, a blood capillary. And both of them has to be simple.
Yes.
Thinnest. So now they can, molecules can exchange between each other, and now you can make urine. So again, blood capillary has to be capillary, thinnest possible, and the kidney part, which we call nephron, also has to be the thinnest possible. Make sense?
Yes.
Okay, how about when you hit the larger 3-layer tubes and tubules? Tubes and ducts, actually, more precisely. Can you make urine?
No.
Too thick?
Yeah.
You remember the same principle applies just like in blood vessels. So what are they doing all day long? Just carrying the urine. Exactly, very good word, transporting. Okay, that's what's all written in here now. So keep it in mind. Okay, let's cover right now the, let me put it here, microscopic structural and functional unit of the kidney. Okay? It is called uriniferous tubules that we never use. And it has two parts, the nephron and the collecting duct system. But that's not, on an everyday basis, we always just going to say nephron.
Yes.
Okay, because but you need to remember that who is there.
Yes.
But when we talk to each other in the lab, we're not going to say, put your pointer on the uriniferous tubule. You know, we just, okay. Anyway, the point is, how many of, so you have to kind of in your brain, okay, and imagine that in the kidney, there are 2 million of this in one kidney. So 2 million little urine factory is cooking for you and cleaning the blood continuously. Okay? However, so this is the urine formation, yes, because it's, so the nephron is for urine formation. So therefore, now you already know how many layers is there? One. Okay, without even looking at the histology. Okay, one more thing. This is not the real picture. This is the stretched version. And I tell you why it is stretched. Because in real life, the two is actually folding on top of each other. But if I show you an image like that, you're going to get lost, including me. So usually when you see this horizontal view, it's always the stretched version, even if they do it for you in physiology.
Yes.
Okay? Okay, now are you guys ready to see the nephron, the structural functional unit of the kidney?
Yes.
2 millions of them. Okay, so, and guys, again, whenever I say nephron, it's urine. I don't want to talk about blood vessels right now, even though I have to a little bit because they put here one capillary. This is the first capillary bed where the first urine shows up. You see the green arrow?
Yes.
That's what I'm trying to show you. We are just cleaning the blood. So this is your first urine in the blue structure, which is called a glomerular capsule. The whole thing together is called renal corpuscle. So the capsule and the blood vessel together is the renal corpuscle.
Yes.
But I don't like that name because then you don't know you are talking about urine or you're talking about blood. But this is just me, okay? But you can use any name you wish as long as you understand that when you are talking about urine, you want to say glomerular capsule or Baumann capsule. That's another name.
Yes.
And this is, I don't like that either. You have to say glomerular capillary. Anyway, so this is the beginning of all things. Okay, this is where the first step, which is filtration, actually. And then comes the purple up and down. And that is called the pars convoluta of the proximal tubule. With another word, proximal convoluted tubule.
Yes.
But I prefer the other way around. Again, you can say whatever you want to say, but I tell you what's the big deal here. First of all, why did I say proximal? Why not distal?
It's closer to the Baumann capsule.
So in by definition, the proximal is always closer to the origin, the beginning of all things. So keep that in mind, okay? So the proximal comes first, and that's the distal, okay? So, And this is going to be called the, as I told you, the pars convoluta. And then it becomes this green thing, and this is called pars recta of the proximal tubule. Now you understand why I separate the names. And so there is, the proximal tubule has a convoluted part and a straight part. What's the big deal here, guys? The big deal is that they have the same epithelium. So it's easier to remember that way. On the other hand, this green part is also have another name. Descending thick limb of loop of Henle. So what does it mean? Descending means that the urine is going south. Thick because the epithelium is still relatively thick, and this whole loop is called loop of Henle. Okay, but for you to remember the histology, the other name is better. That the pars recta and the pars convoluta of the proximal is the same epithelium. Okay, and what is happening? Look, the urine is leaving the cortex area and entering the medulla, and this really thin part is called the thin descending loop of Henle. Thin because it's thin, and descending because the urine is still going down. Then the urine is going to make a U-turn, a loop, and now it's coming back to the cortex. Look, so therefore now this branch is going to be called ascending limb of thin loop of Henle. Guys, it's very important. If you use the name loop of Henle, you have to always say thin or thick. Okay, but if you don't use the thick loop of Henle, all you say is pars recta of proximal or pars recta of distal, then you don't need to worry about it. Only the thin loop of Henle you have to say. Okay? So now look at the urine is coming up, and now suddenly a abrupt change, you see? And it becomes again a little bit poofy, right? What is going to be the name of this? Pars recta of the distal tubule. The straight part of the distal, okay? And yes, it has another name. Let's ascending thick loop of Henle. But does that help me? No. The other name helps me because both the straight and the convoluted part has the same epithelium. Okay? Yes. But otherwise you can do whatever you want. Just don't mix up the epithelium, because I just want to tell you, that's what I created for you as objective for TBL. I didn't put the whole lecture there, that, you know, because I don't believe in that. I want you to know the nephron and all the epitheliums in them, which is coming. Okay. We are doing just the parts so far. Okay, then look, there's a little connection between this is the nephron, okay? Okay, and I also labeled here for you. You see this line here? That's the border between the nephron, which is the secretory part of the gland, yes. And under this purple line comes the collecting duct system, which is similar to the ducts of the glands. And on this image, the blue. Okay, so that's where, by the way, when you get the embryology lecture, you will see the nephron and the collecting duct system is developing separately, and they join together at one point. Okay, so is that clear?
Yes.
Okay. Just on the side, even though on the image they don't show the whole collecting duct system, there is a cortical, there's a collecting tubule, which is the connection between the two. Then you have a cortical part in the cortex, then you have a medullary part in the medulla, and you have at the papilla also a papillary collecting duct of Bellini. Okay. Okay, there are two kinds of, so no more question here, you guys are clear?
Yes.
Okay, and you have to imagine only 2 million. Okay, just remember that. Okay, now guys, this is the not stretched version. So let's look at it. It is the way it is supposed to be. That the proximal and the distal are kind of on top of each other, kind of. But what is very important to see is that you see this is your balloon, glomerular capsule. You see the blue continues. The urine is going to go through the pars convoluta, pars recta of the proxima. That's all blue. Then comes the thin loop of Henle down, you turn up. Then comes the proximal. And look what proximal is doing. He is actually giving kissi to mommy renal corpuscle. Look, they're hugging each other. Bye, mommy, I'm leaving.
Yeah.
I'm going to the toilet. Just kidding. But that's really what it is. But look at it, the distal tubule and the glomerular capsule, does the urine flow between each other? No, it's just passing by. Hi, mommy, and moves on. Okay? So this is what we call the macula densa, but that's another lecture. Okay, there are two kinds of nephrons in the body. There is the cortical, that the whole nephron is pretty much in the cortex, just a little bit in the medulla. The other one is called juxtamedullary nephron, and which is what you're gonna see very nicely on the laboratory, that the thin loop of Henle is gonna go all the way to the papilla, which is the tip of the pyramid. Okay, and what's the difference between the two guys? The first one, the cortical, is only in the urine formation. The juxtamedullary nephron is special. It is involved in urine formation and counter current multiplier, creating the concentration gradient in the medulla is going to drive you crazy in physiology. Okay, but that's what it does. And this is the way we can do concentrated urine. Okay, so now, guys, we are at the junction. Which junction? The junction of the tip of the pyramid. So watch, I'm showing you very carefully. So this is your one pyramid, okay? Cortex, medulla, and I put the blue arrow, very important. From here to here, microscopic tubules, only simple epithelium. One layer. There's nothing else, that's just a teeny tiny simple epithelium with a little basement membrane. Nothing else. From top all the way until you hit the P, which is the papilla. And then macroscopic tubes begin. And again, observe tubule, tube. Tube is the macro, tubule is the micro. When the word gets longer, the structure gets smaller. It's basic principle in Latin terminology. And guess who shows up? Yay!
Stratified.
Finally, the stratified epithelium shows up. So, where is the end of the urine formation?
Papilla.
Exactly. The last time you can do modification of the urine is in the papillary collecting duct of Bellini, labeled with B. After that, look what happens. The urine is exiting like this. I put it there for you. Now on the model, they didn't put holes on the papilla. Bad model. I mean, otherwise it's a good model. But basically about 30 on the model we have only one papillary duct. But actually 30 papillary duct is actually shooting urine from the tip of the pyramid to the minor calyx. So who is looking at each other? Actually, the papillary duct of Bellini on the microscopic side and looking down into the valley of the minor calyx, where the three layers begin, stratified epithelium, transitional epithelium all begin. So therefore, can I make urine after this? Can I modify the urine after this?
No.
Muffy. Okay? So urine formation is only on this part, okay, up till the pyramid. Now, I need to introduce you to one more name. I already used the Bellini, papillary duct of Bellini. This is the actual, did we use this name papilla before? Papillary muscle. What?
Papilla of the thumb.
We didn't do skin yet, right?
No.
No, okay. Anyway, the point is papilla is, again, a tongue papilla.
Yeah.
Yeah, tongue papilla, yeah. But anyway, anytime you have a structure like this, but now it's like this.
Yeah.
Yeah, so that's basically, papilla is a very common word. Anytime you see a little curve kind of thing, is papilla. But, so that's for that. But what about the AC? It refers to, where did I put it? Somewhere, area cribrosa, which means the spaghetti, when you have the spaghetti and you want to get rid of the water, what is that called? Sieve. Drainer. Okay, so the place where the 30 holes of the papillary ducta bellini are, that holes, that area is called the area cribrosa. Meaning it looks like a spaghetti drainer. Okay, so all refers to different. Papilla refers to the curve, the area cribrosa refers to the holes, and the papillary ducta bellini is the actual end of the nephron. End of the nephron, and looking down into the valley of the minor calyx. So what? Okay, very good. Any question? Kapish? Fahamt? Good. Okay, now comes histology. So now we understand how the urine is going in different parts of the nephron. We also know starts in the cortex, continue in the medulla, comes back to the cortex, blah, 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 blah. We know the names. Now we have to find the name of which kind of simple epithelium is going to be here. All of them. The simple squamous, the simple cuboidal, and the simple columnar. They're all there. All three of them. Are you guys ready?
Yes.
Okay, let's do it. And remember, this is the major thing on your tibia, that you know what epithelium is where. And remember, how many layers is here? One. Just imagine there's nothing else, just this teeny tiny simple epithelium with a basement membrane. That's it. It's like crazy thin. Okay, so as we said, this is your glomerular capsule or Bowman capsule around this capillary bed where the first step of urine formation occurs. Okay, look at it has a wall here. This is called the parietal layer of the Bowman capsule. And they didn't do a good job drawing the epithelium, but that's why I put that for you. That this is the parietal epithelium here is actually a regular normal simple squamous epithelium holding the urine, filtrate. Okay, and then you see the other wall here facing the capillary?
Yep.
That one is your visceral epithelium. But guys, that visceral epithelium, also simple squamous epithelium, but so heavily modified that it has a new name. It's called podocytes. And we're gonna talk about it later, so not right now. But basically, we start out with two simple squamous epithelium in the Bowman's capsule. Now, the urine is gonna flow out and enter the proximal tubule, the convoluted and the straight part, which has the same epithelium. Which one? This one, which is the simple cuboidal epithelium with microvilli.
Okay.
Good?
Yes.
Tons of microvilli on the top. The moment you see microvilli, what comes to your mind first? Absorption. Absorption or reabsorption. Okay? And you can see lots of mitochondria. You can see it on electron microscopic images. Okay, so now where are we going next? We are bye-bye cortex. We are going to the medulla right now by the thin loop of Henle. And the thin loop is thin because it's thin. That's why it's called thin. Okay, why? Because all you see is, you see I put here for you, that was such a hard work too, because this is, I copy pasted these images for you. Yeah.
Yes.
Okay, simple squamous epithelium. Okay, guys, in the thin loop of Henle, nothing else fits. Just remember that it should give you a trigger. Thin, simple squamous. It cannot be cuboidal, it cannot be columnar. Okay, now we are coming back toward the cortex, right? And we are hitting the pars recta and then the pars convoluta of the distal tubule. And what is the epithelium here? This. Simple cuboidal, no more maybe a little microvilli, but not significant. Okay? Now you guys see the beauty of knowing pars recta, pars convoluta, because it's one epithelium. Okay. Okay, and then when the simple when the distal convoluted tubule joins to the cortical collecting duct system, okay, and you're gonna see cortical collecting duct, which is in the cortex. Very logical name. Medullary collecting duct, because it's in the medulla. And papillary collecting duct of Bellini, it is somebody's name, because now you are at the papilla of the renal pyramid. And as you can see, I did not put here histology because it was too busy, just too busy. So the next slide I did that, okay? Here we go. Separately because it doesn't fit on the other one. But again, here is the cortical, the medullary, and the papillary, all three of them. Now let's do histology. This is still simple cuboid epithelium, just like the distal tubule. Yes. What is interesting that here at the cortical area, you're going to have two kinds of cells. They have dark cells or intercalated cells, light cells or principal cells. But I want to make sure that you understand. It is simple cuboid epithelium. So some cuboid epithelial cells are lighter and called principal cells. And they respond to ADH. Some cells are darker, and this actually really refers to the cytoplasm, but I will show it to you in the microscope anyway. Intercalated cell. What does it mean, intercalated? Somebody stuck between. Like you have a lot of principal cells, but here and there you find intercalated cells or dark cells who are involved in pH control. You're going to learn it in physiology. You can see lighter and darker. However, the moment we are entering medullary collecting duct, no more intercalated cells, only principal cells. So according to histology book, unless the guys tell me if the physiology people say anything different than I say, because sometimes the books don't agree. Not me, the books. But anyway, but again, this is a simple cuboid epithelium. So if I say, give me the name of the epithelium, you have to say simple cuboid. Okay, then give, and what is the name of the cell in this epithelium? Principal cell and intercalated cell. But who is the majority? The principal cell. Because intercalated means just sporadically, here and there. Okay? But I was going to say something else, but I forgot. Okay, anyway, so let's look at the papillary collecting duct of Bellini, which is, look at guys, now it's simple columnar. And it has a little bit of microvilli. You can see it very nicely in the microscope. Okay, and same thing, only light or principal cells for ADH. Okay. No more intercalated. Okay, and so what happens between the cortex and the papilla? The epithelium is gradually getting taller. Yep. From cuboidal to columnar. Why? Because the major feature of the collecting duct are that they are collecting. What does it mean? Merging, 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 merging. So therefore, the urine volume is getting higher and higher after a merge. So you technically need a little bit of thicker, stronger epithelium. Yeah. And is the columnar stronger than the cuboidal? Yeah, it is. One more thing, and now I remember what I was going to say. Again, another principle I taught you several times. If there is a cell that is special, always got a name. These two guys has a name. Because otherwise, if we don't give names, what am I going to say? Cuboid epithelial cell. The name of the cell is cuboid epithelial cell. But because they are so special by their function, this cuboid epithelial cell earned a name. Yes. Okay, so the principle applies. You see, these guys, this columnar, how about the name of this guy?
Simple columnar.
It is, if you just, histology is columnar epithelial cell. But does it have a name?
Yes.
Principal cell. And this is again another weird thing that I mean, I know quite a bit of histology, but I don't remember seeing that. Principal cell can be cuboid, can be taller, and it can be columnar. So the principal cell looks like growing up from cortex to the through the medulla and the papilla. So that one type of cell with the same function has different histology is a very unique thing. Okay, capish?
Yes.
Okay, if you like table, here it is. Okay, if you don't, you can skip it over, we covered it all.
Okay.
But I love tables because it's all in one, like that. The only thing is that you can't, when you read the table, you can't jump around.
Yeah.
You have to go systematically. Let me look at start on the top, on the left side, and then, yeah. But you see what I was spoiling you guys? Look at this, simple. The whole nephron is simple epithelium, and then finally here at the minor calyx, it doesn't show very clearly, minor calyx, finally, boom. Sorry I scared you. Wake up time. Finally stratifies epithelium, which is the transitional. Good?
Yes.
Okay, so this is the next section in our in my lecture is talking about the blood vessels of the kidney, so that we can bring together, you remember, the nephron and the blood vessels, the capillaries, to make urine. But that's not what I want to do. Number one purpose is that you are ready for TBL. So let me show you one potential question. It's all about histology, okay? So it's really not that hard. But let's say here's your histology, okay? So I'm gonna say what kind of two epithelium junction between the glomerular capsule and the proximal tubule. Because suddenly it used to be this epithelium, now it's another. So that's why I call it, there's like a junction there.
Yes.
So what was the epithelium? It's all written on the thing, so just read it off.
Simple squamous and simple cuboid.
Simple squamous is correct. Remember both of them, but this has to be, you always have to put the microvilli, guys. Okay? Because that's the way it's going to show up on the question. So, what kind of cells are sitting in the distal tubule? Cells, not tissue. Actually, cuboid epithelial cells.
Yes.
Because it's simple cuboid epithelium. What I'm trying to teach you is that when you say tissue, you have to put there simple. When you talk about just one cell of that tissue, you don't need the simple. You just say cuboid epithelial cells. And technically, one of you said that the distal, you actually technically, some of the distal tubule already have principal cells. So there's like a transition from transition to collecting duct, and you're gonna see it in physiology. But for our purpose, I think it's better this way. But don't be surprised. There is a transition to become collecting duct system. Okay, so then what is the junction? What kind of epithelium here, junction here? At the proximal and the thin loop of Henle.
Simple cuboidal epithelium with microvilli, simple squamous.
Yeah, so proximal is simple cuboid epithelium with microvilli written here, and it becomes simple squamous. Very good. The next junction?
Simple squamous is epithelium with
Simple cuboidal with no microvilli.
Yeah, no microvilli, exactly. And then here is actually the same.
Yeah, but
And as I told you, some distal cuboid epithelial cells actually start looking like cortical, but collecting duct, but just but either way, the histology is the same. It's like simple cuboid. So simple cuboid to simple cuboid, basically. And then the collecting duct system we just described, it becomes thicker, thicker, thicker. Okay? So, and where do you have the junction between the micro and the macro? At the papilla, or
At the base.
area cribrosa,
Yeah.
or, and again, who is going to look at each other? And again, I'm looking for nephron structure, not, I mean, papilla is also good, but I want the nephron, the name of the nephron. The name of the nephron is, the papillary duct is looking at the minor calyx. And by the way, so that you can see very clearly, these are the teeny tiny collecting ducts are coming toward the papilla. And you see this huge tube here? That's your minor calyx, and you can see it's much ridiculously, it's like you can see it with your naked eye. The 3 layer is there. You see how, that's where your junction is. What is the 2 epithelium you are looking at each other over there? From the Bellini is simple
Columnar.
columnar.
Yes.
Yeah.
And looking at, say hello,
Stratified squamous.
transitional.
Oh,
This is where transitional epithelium begins.
Yes.
Okay? But you are correct, stratified. Because you want to create that this is where every simple, and this is where stratified begins. But then when you want to, give you the specific names, then you have to say simple squamous, simple cuboid, simple columnar. And then for the stratified, you need to say transitional. Okay? Good? And you see the minor calyx is actually the beginning of the ureter. We're going to talk about that too. So what does it mean? The 3 layers just here, boom, begins. Inside the kidney, where the minor calyx and the major calyx are, and we're going to talk about it again, but is the walls are still very thin because you are still in the kidney, not much space. But the moment the ureter, you see how it's all connected? The ureter exit, all layers start becoming thicker.
Okay.
All 3 layers. Okay, so now what we're gonna do is not the blood vessels because it's actually very simple, but I want to more get you ready for looking at the same thing in the microscope, meaning the lab next week. And then tomorrow we cover everything else. But anyway, even though we didn't do blood vessels today, you can already see that this is a capillary, right? Red blood cells in one line, okay? So here we go. So what we are going to do is going to look at the cortex, guys. And okay, so again, here is the big name. We just say nephron. I put it there here for you. And the reminder. And there are other stroma cells we're gonna cover, but not today. And the first part, you remember the first part is the Bowman's capsule.
Yes.
So let's look at the Bowman capsule. And you already know some of this already. So this flat nucleus here, and this flat nucleus is very good, parietal layer of the Bowman's capsule.
Yes.
Now this, where I put the one at the edges, those are your
Visceral.
podocytes.
Yes.
So the modified simple squamous.
Yes.
Okay? And number 3 is the space between. Yeah, that's the, you can say lumen, cavity, but I believe the physiology people are going to say Bowman space, right? So that's where the first urine shows up. How? You see the capillaries with the red blood cells?
Mm-hmm.
So the urine is going to come from through.
Yes.
Okay, we're going to talk about that also. Okay, so that's short and sweet. However, one more thing, very important. Who is here? Kissy, kissy, mommy, mommy. The distal, as I told you, distal convoluted tubule is coming by to the original. This is the same urine. What is in the Bowman space went through that distal tubule. They are the same nephron.
Yes.
What's the big deal, guys? Very important control center. Saves your life. It's coming tomorrow. I don't want to talk about it right now because I want to focus on that whatever we did now, you can see it in the microscope. Because so far I showed you on model and images. Okay, so we just skip this. Filtration next time. The juxtaglomerular next time. Okay, here we go. Okay, tubules in the cortex and what is cortical lobule. What I really want you to understand, okay, switch your little brain, we are in the cortex. Okay, and how is the cortex organized? Okay, this is a very big word. Alternating, convoluted and straight. Convoluted tubules, straight tubules. Convoluted, straight. Wherever you see convolution is called the labyrinth. Why? Because it looks chaotic. Okay, so therefore, how does convoluted tubules you're going to anticipate to see on the microscope? They are coiled snakes. They are convoluted. You cut it in half, what are you going to see? Circles.
Oh, because
they are always circles, guys. Anytime you see a convoluted anything in the microscope and you cut it, you're going to see circles. Okay? And the straight tubules, that part where the straight tubules are running is called the medullary ray, like sunshine. Sunshine never goes like this. Excuse me, I go around you. Sunshine is always straight. So wherever you see convolution, labyrinth. Wherever you see straight, is straight, sunshine, medullary ray. Okay, and they are alternating. Now I'm going to show you on the slide. Okay, so here is a zoom out picture, and watch very carefully because I'm showing you. Straight, convolution. Straight, chaos. Straight, chaos. Okay, so the chaotic is the labyrinth, the straight is the medullary ray. Okay, and now I zoomed in. Okay, identification of the cortex. Guys, the renal corpuscle or Bowman capsule is the easiest thing to identify because it looks like little circles, you see?
Yeah.
Then you know I'm in the cortex. And the moment you don't see any, balloons anymore, and in fact the medulla looks, on this cut is not very clear yet, but some cut is like so straight, ducts in the medulla that it looks like striation. There's no convolution in the medulla. But do you know why? Only God knows, of course, but I always have these little, theories in my mind. When you do convolution, you slow down the flow of the urine. So you have more time to do exchange. Once you are in the medulla, major part of the urine formation actually already occurred, and so basically you don't need that slowing down function anymore. Yeah.
Makes sense.
Okay, so now let's look at who are the convoluted guys in the labyrinth. Number one is the renal corpuscle, the balloon. Number two, convoluted part of the proximal. So what I'm going to look for? Circles. Convoluted part of the distal. What am I going to look for? Other kind of circles. Now I'm going to show you which one is which. Okay, so you see I labeled here, this is your cortical labyrinth. Circles, not an accident, okay? This is the renal corpuscle. This is your balloon. Okay, and now focus on this guy. You see this circle? I put here for you, pars convoluta, fuzzy pink circle. So, why is it fuzzy? Exactly, very good. From the microvilli. Why is it pink? Because the cytoplasma is more than the nucleus. Look, there's only like 1 or 2 nucleus shows up. This is very typical. One more thing, you're always gonna see more proximal circles than distal circles. Why? Because the proximal tubule is longer. So you're gonna see more circles. So the proximal convoluted is the easiest to find on the planet. Many fuzzy pink circles. Why is the nucleus doesn't show up frequently? Because the cuboid epithelial cell with microvilli is large. So the knife goes through and misses the nucleus. Okay? So that's your fuzzy pink circle, look. And here. Okay, what about the distal tubule? The opposite. Only few and looks more because our cells are small, so the knife is going to go through the nucleus, and then therefore you're going to see more bluish nuclei. The cytoplasm is still pink, but you're going to see a lot of nuclei, so you're going to have a not fuzzy blue circle. Let me show it to you. Look at this. The lumen is clearly open, no microvilli, lots of nucleus, makes it more bluish. Make sense?
Yes.
Okay. And yes, we have to analyze the macula densa next time. So do you guys understand?
Yes.
Fuzzy pink circle, proximal. Not fuzzy blue circle, distal. Okay. So now let's look at the sunshine. Who is in the sunshine? We already know. The pars recta of the proximal. Guys, I always go by urine flow, always. And I want you to do the same. No jumping around. So proximal, pars recta of the proximal, then
Distal pars.
No, the
pars recta of the distal, and then comes the cortical collecting duct.
Okay.
Because remember, we are in the cortex.
Yes.
Okay, so let's identify. The easy peasy, because just because it's not circle but long, the histology is the same. Okay, so look at this. Do you see these pink guys straight going down here?
Yes.
Those are the pars recta of the proximal. Now, do you see these bluish guys here, straight coming down? Very blue. That's the pars recta of the distal. So now, how do I know which one is the collecting duct, guys? The cytoplasma is, you remember this is more pinkish, this is more bluish. The cortical, the entire collecting duct system is, you remember light cells?
Yes.
Or principal cells. Light cells means the cytoplasma is white.
Okay.
And look at, you can see it very nicely. This is a cortical collecting duct, white cytoplasma. Nucleus. Lots of eyes are looking at you.
Yeah.
You see? White, 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 white cytoplasma. Everywhere white cytoplasma. That's your identification. Point 4. Collecting ducts in general, with another word, principal cells. Okay? Okay, so any more? This is showing you, look, the fuzziness of the proximal tubule in cross section, and very pinkish and large, and many proximal. Do you see? How many distal do I see? 1, 2, and 3. And look, no fuzzy, very blue, lots of nucleus. So even if the color is not exactly what the previous was, you can still figure out. Less number, very blue, lots of nucleus, and the lumen is very clean for the distal, and the proximal is the opposite. Okay, another one. So let me just show you. Yeah, I wanted to show you this. So do you see again? Medullary ray, labyrinth. Medullary ray, labyrinth. Medullary ray. It doesn't show very well here. Medullary ray, labyrinth. Medullary ray, labyrinth. See the organization of the cortex.
Yes.
And now look at what I said you a minute ago. In the here in the outer strip and the inner strip of the medulla, is the tubes are kind of cut in cross and little oval sections, but here when you enter the closer to the papillary area, look at this is what I said, it looks like striation. Because who is sitting there? Only straight tubules and ducts. Which one? Thin loop of Henle?
Yes.
Up and down?
Yes.
This is that. Actually, I couldn't dare to shut up for me. Okay, so, and who else is there? The papillary collecting duct of Bellini. And who is waiting on the other side? Yeah, and macroscopy starts with what epithelium? Stratified transitional epithelium. Yeah. Okay, done.
That's it.
That's why I was rushing so much, because I put up the timer for me. Okay, yes, we are done for today and we continue tomorrow, but I really believe you already very, you are well prepared for TBL, and also next week when you look at the different part of the kidney. But tomorrow we continue the rest, okay?